Hi, my name is Olafran Hadush, and I'm your teacher for the MME 3111, that's Thermodynamics for Materials. You can call me Waldi. As you see, my name is a little bit long. I live in Bishoftu, Ethiopia. In my part-time, I work and take care of my 3 children. I look forward to working this semester with you. So when we come to the course, we are going to talk about the 3 laws of thermodynamics. I really like thermodynamics, energy, and so on. Who does like energy? So let's go through the course. When we see the first law of thermodynamics, there is one equation that's U is equal to Q plus W. U indicates the internal energy, W indicates the work done, and Q indicates the heat. So delta U is just really showing the energy as a universe. So change of energy will always equal work plus heat. In the conservation of energy, simply that energy cannot be created or destroyed. So conservation of energy. That comes from, for instance, if you see our body, that energy comes from the food what we eat. And when we see the car, from the composition of the fuel, we can get the heat energy. This is the transformation of the energy. Here in the first law of thermodynamics, there is one terminology so-called enthalpy that's interchangeable with Q. In nature, the first law of thermodynamics is a conservation of energy. The second law of thermodynamics it's also very interesting. I also really like this. I find this one in my life. Everything going disordered. Here is the technical definition. Spontaneous process, and we will talk about this one that increases entropy of the universe. Increase the entropy of the universe is spontaneous. In any process that moves nature towards equilibrium, this is obviously a true phenomena. Everything goes to the equilibrium. A spontaneous process is once you start it, it will continue on its own. This word is entropy. Entropy is the measure of disorder that's designated by S. So this is saying that anything naturally that moves towards the equilibrium is going to increase the disorder of the entire universe. And then the third law of thermodynamics is at absolute zero, there is no entropy. That means there is no disorder. So just reminding absolute zero is when Kelvin is zero. So the coldest temperature possible, or reminding that negative 273.15 degrees centigrade is relative to temperature. What cool about the third law of thermodynamics? Here is the idea, even if in solids we are going to have atoms that are in a fixed position, that's what makes a solid. Like this solid and all those atoms are in fixed position, but the atoms themselves still vibrate like this and at absolute zero. Finally, there is one good terminology that gives free energy. The application in the materials of thermodynamics we will see in the coming chapters, but generally the Gibbs free energy is equal to enthalpy minus temperature delta entropy. The temperature that comes from third law, the entropy that comes from the second law, and the internal energy or enthalpy that comes from the first law. This is the combination of the 3 laws. This is very crucial to the material engineering, for instance, in extraction of materials and so on. Then when you need to revise it, this video, you can find it in my private YouTube site, so you can download it and revise it. Thank you for having time.